Hey everybody, how are you doing? Miss you guys. Some of you guys are doing a fantastic job, and I'm so glad to hear that. And I'm so glad to see that. The first few lessons that we did are kind of a recap of what I taught you in class and then kicked it up a little bit more. This is the last lesson that's kind of a repeat of things that I taught you in class, and we're going to kick it up a little bit more. And then starting tomorrow, after your quiz and stuff, or to your quizzes today, but starting tomorrow, we're going to learn some new stuff. And I put some videos on for you to take notes this weekend, which very few of you turned in actually. So you got to watch those videos so that you understand what we're doing tomorrow, okay? Tomorrow can be easy or it can be very, very confusing. If you watch the videos, it'll make it a lot easier. If you don't watch the videos, you're going to be lost, okay? Keep up the good work. I go to the doctor late this week, Thursday or Friday, and I can't come back to school until I can walk on my foot. So that's what the goal is. So keep up the prayers. I appreciate it. And hopefully I'll be able to walk this week and I'll be able to come back into school. All right. Anyway, don't think you really need the camera, but as a recap of what we're going to do today is we're going to go back. Remember, go back and find the angle. And when we do that, we use our calculator and we hit the second sine key, and that'll give us the arc sine or the inverse sine, second cosine, which will give us the arc cosine or the inverse, and second tangent, and that's going to give us the arc tangent or the inverse tangent. Remember, your calculator has to be in degree mode. So check your calculator, make sure it's correct. Go grab them real quick. Open up your Math Nation book and let's get going. You probably don't need to see me on this video. So I'm going to disappear and I'm going to upload my file. It's a Math Nation file. And you guys are going to be on page 396. All right, so here we go. Again, we're doing inverse trigonometric functions. And then another name for those are arc cosine, arc sine, and arc tangent. And basically, we're just using the second sign. All right, example 1. In triangle HRC, they give me the measure of the right angle. So if we have the right angle, then we know we have the hypotenuse. And if we have the hypotenuse, and they're looking for us to find theta or angle C, that according to theta, this is the opposite. And if it's not the opposite, it's not the hypotenuse, then it must be the adjacent. So we can use adjacent and hypotenuse to find the missing angle. And that's nothing more. Whoops. Sorry. That is nothing more than cosine. The cosine of some angle theta equals adjacent over hypotenuse. And in order to find it, we take the ratio and put it in the parentheses and hit second cosine. Okay, so let's get your calculator out. Everybody should have a calculator. You shouldn't be scrambling over behind the desk to get a calculator, but you should have one. All right, take 8 divided by 13 equals second cosine, and we should get approximately 52.0 degrees. And for all practical purposes, today we're going to round to the nearest tenth. Okay? Now it says, what equation can be used to find the measure of CHR? And CHR is angle H. H is the vertex. It'll be in the middle. Okay? And we already know that 90 minus 52 should give me the other angle, right? Because these two angles are complementary. So 90 minus 52 gives me 38. We know that that angle should be, 38 degrees. But if we're coming from the other angle, if we're coming from H, we should be able to say, hey, that is opposite over hypotenuse. And which trig function is opposite over hypotenuse? Well, that would be sine. The sine of 8 over 13, negative 1, should give me what we've anticipated was 38 degrees. So let's take and put that in the calculator. 8 divided by 13 equals second sine, and we get that 37.97, or approximately 38 degrees, which we already knew what that was going to be, but now we're using our trig functions to find those opposite angles. Okay. Let's go back and let's look at that again, just as a repeat. First, we looked at theta, and we said that was adjacent over hypotenuse. So we use cosine. And then when we came from the opposite direction, when we came from H, it was no longer the adjacent side, but that became the opposite side. And the hypotenuse doesn't change, and that became sine. All right, let's look at the next one. And we did this. It says make sure that it is in the degree mode. And we did CHR. So we said sine of some angle equaled 8 over 13. And when we go back and put it in, that's when we have to use that negative 1 key. All right, now they're giving me triangle WLT is a right triangle with the measure of WLT is 90 degrees. The distance of TL is 11, and the distance of WL is 23. What is the measure of the angle TWL? All right, always draw your picture. And the most important angle is your right angle. And if T is in the middle, that's your vertex. So this has to be T. All right. Now the other two letters, it doesn't really make much difference where you put the W and the L, but you're going to put it in the picture. We've identified the most important angle. Oops. Didn't mean to do that. The most important angle, 90 degrees, which was T. And then we just simply put in our lengths for the other ones. The distance of T to L is 11, and the distance of W to L is 23. What is the measure of TWL? W is the vertex, so they're looking for this angle, and they're giving me opposite, and they're giving me hypotenuse. Opposite and hypotenuse, some old hippie. Sine of the angle equals 11 over 23. And remember, when we go back to find it, we have to hit the -1. So take your calculators. 11 divided by 23 equals second. This time we're doing sine because they gave me the opposite. We're rounding to the nearest tenth. All right. Guys, do it on your own before I just give you the answer. 11 divided by 23 equals second sine. Go back and find it. And you should get 28 point. If we're rounding to the nearest tenth, you should get 0.6. Give yourselves a pat on the back if you got 28.6. All right, number 3. Angle B is the right angle. Determine the measure of angle BNW. N is in the middle, so that is the vertex. So we're looking for this angle, or theta. Okay? And they say if N is 36, that's the distance of N, and the distance of W is 77. All right? According to this picture, what trig function are we going to use? Well, according to N, this is my opposite, and according to N, this is my adjacent. And which trig function is opposite and adjacent? You got it, tangent. So tangent of the angle we're looking for is going to equal opposite 36 over adjacent 77, and we go back and find it. Take 36 divided by 77, second tangent, and what do you get? Come on, don't be lazy. Pick up your calculator. Do it for yourself. 36 divided by 77 equals second tangent, rounding to the nearest tenth. And what do we get? Approximately 25.1 degrees. Okay. When it comes to the problems that don't have a picture, remember to draw your picture. All right. Gabriella used the inverse of sine of 77 divided by 85 to find the measure of angle BNW, or angle N, since it's the vertex. Determine if the sine of 77 divided by 85 results in the same degree measure as your answer. looking at the previous problem, BNW, we got 25.1. So they're saying, hey, is the other direction going to give me the same answer? So let's try it. 77 divided by 85 equals second sine. We got 64 degrees. Let's try it again. Make sure we got the right answer. 77 divided by 85 equals second sine 64.9 or 65 degrees. So the answer is no, it's not the same angle. 77 over 85. Wonder where they got 77 over 85. Well, 77 was one side, 36 was the other. 85 must have been the what? 85 must have been the hypotenuse. Is 77 the opposite? And if we look back at the picture, I don't know why, little turkey stuff moved on me. The opposite was 36. .36 over 85 would have worked. 36 divided by 85 equals second sine, and we would have gotten 25 degrees. Okay. .36 over 85. And if we take the sine of that, that would give me the same answer. But you would have to have the opposite over hypotenuse. And in this case, they didn't give me opposite, they gave me adjacent. Wrong trig function. All right. Let's try another one. Number 1, 7.5. In triangle KDR, where the measure of angle KDR is 31 and the measure of KDR is 90 degrees, and the distance of KD is 17, what is the length? Now we're going back to finding lengths and not angles. So this is not an inverse. Why is it not an inverse? Because they're giving me the angle. So we got to make sure that we have our picture. Okay, D is the vertex, and that's 90 degrees. Then the other two letters must be K and R. And they say that the angle of K, I'm sorry, not the angle of K, but the angle of DKR is 31. So K is the vertex, so this is 31.2. The distance of K to D is 17. What is the length of K to R, which is the hypotenuse? So which trig function do we need to find the hypotenuse? They want me to find the hypotenuse. They give me the adjacent. So which trig function is adjacent in hypotenuse? Come on. Which trig function is it? You're right. According to K, it's adjacent over hypotenuse, and that would be cosine. But this time they give me the angle. So if they give me the angle, we simply plug it in and use it. Adjacent, 17. And what we're looking for is the hypotenuse. Now remember, we said if the variable's on the top, easy peasy, just multiply. But if the variable is on the bottom, we simply take what's on the top and divide it by what's on the left. Let me go back and say that again. If the variable's on the bottom, we take what's on the top, 17, and simply divide it by what's on the left, and that's the cosine of 31.2. And remember, we put that in the calculator, 31.2 cosine, and the magic thing is we hit the equal key. Rounding to the nearest tenth, we get 19.87 or 19.9. All right, one more time. Let's go back and say that again. This time we're not finding an angle measure. It's not an arc sine. This time we're just using it because they give me the angle measure. If you know what it is, simply plug it in and use it. According to this picture, we have adjacent and hypotenuse. My adjacent is 17. My hypotenuse is the variable that we're looking for. If the variable's on the bottom, we simply take what's on the top and divide it by what's on the left. It goes in your calculator like this: 17 divided by 31.2 cosine. 17 divided by 31.2 cosine, and you should get 19.9, or simply 20 degrees. All right. I'll let you try number 2 on your own. Draw your picture. Don't wait for me. I'm not drawing the picture. You draw the picture. Where does your right angle go? Are they giving you an adjacent, an opposite, a hypotenuse? What are they giving you? MA is 20.7. The distance of M to U is 9.1. Notice they're asking you, what is the measure of the angle? Since they're giving you the lengths and they want the angle, you're going to have to use the inverse function. And they want the measure of angle M. The measure of angle M is what? And which trig function did you have to use? (9.1). Okay, I got 63.9. Is that what you got? Draw your triangle. Most important angle is what? U. That means M and A could be, and we're focusing on M. Make sure you get this answer. Finish labeling your picture. MA is the hypotenuse. MU is 9.1. That's my adjacent. Which trig function is adjacent over hypotenuse? Okay. Number 3, they're asking you for a length. Notice they give you the angle. This is nothing more than what you've been doing before. ND is my hypotenuse because it's opposite of the right angle. What do they give me? Hypotenuse is what I'm looking for. This would be opposite, and what they're giving me is adjacent. Which trig function is adjacent and hypotenuse? You got it. Same thing as up here. That's your cosine. They give you an angle. Simply plug it in and use it. What is the adjacent? 36. What they want you to find is your hypotenuse. Again, if your variable's on the top, simply cross multiply. If your variable's on the bottom, take what's on the top and divide it by what's on the left. It's going to go in your calculator. 36, 65, then hit cosine. What do you get? What'd you get? What'd you get? What'd you get? I got my hypotenuse was about 85 units long. Let me do it again. Make sure I didn't make any mistakes because I don't got you guys there to tell me. 36 divided by 65 cosine equals, don't forget the equal sign, and I get 85.1 or 85.2. So we're just going to leave it at 85. Or 85.2. Okie dokie. All right. Amelia and Henry found the length of distance of NK using two different